Welcome to lesson 5, the intersection of a line and a parabola. We can determine how many points of intersection there are between a given line and parabola, and we do that by following these steps. First of all, we're going to substitute the equation of a line into the parabola. That will lead to a quadratic that we can tidy up into the form ax squared plus bx plus c equals 0. Then we're going to use the discriminant to determine how many points of intersection that there may be, remembering that if the discriminant is greater than 0, then there'll be 2 points of intersection. If the discriminant equals 0, there'll be only 1, and if it's less than 0, there'll be no points of intersection. Finally, we solve the quadratic to find the coordinates of any points of intersection. Let's look at some examples. So in example 1, we're being asked to prove that the line y equals 6x minus 7 is a tangent to the parabola y equals, and that should be x squared plus 2. And then we're also needing to find the coordinates of the point of intersection. So we're proving that it's a tangent. To do that, we're going to start by substituting the equation of the line into the parabola. Effectively here, we're just making them equal to each other as they're both expressed with y as the subject. So x squared plus 2 equals 6x minus 7. We now rearrange this to one single quadratic in the form ax squared plus bx plus c equal to 0, and you'll see that that becomes x squared minus 6x plus 9 equals 0. Now, if we know that the line is a tangent, then we know that for this quadratic, the discriminant b squared minus 4ac should be 0. So we have a quick check of our coefficients, a, b, and c. And tangency means that b squared minus 4ac must equal 0. And that's what's going to allow me to prove that we have a tangent here. Because if we check that for this quadratic, it will be minus 6 squared minus 4 times 1 times 9, or 36 minus 36, which is 0. And that is proof of one sort that we have a tangent. So we would say as b squared minus 4ac equals 0, there's only one root, only one point of contact. So that means that we have a tangent. That's one way to prove that the line is a tangent to the parabola. We are being asked to find the coordinates of the point of intersection, so we'll now solve the quadratic, x squared minus 6x plus 9 equals 0, to find that coordinate. And we see that we have here a perfect square that factorizes to x minus 3 all squared equals 0, giving us x equals 3. We can quickly find the y-coordinate by substituting x equals 3 into the equation of the line, y equals 6x minus 7. So that'll be 6 lots of 3 minus 7, or 18 minus 7, which is 11. And that means that we have our point of contact as 3, 11. Our point of intersection, sorry. In example 2, we're going to look at a problem where we have to find the equation of a tangent to a curve, this time y equals x squared minus 5x plus 10, and the tangent must have a gradient of 5. So firstly, if we're looking for a straight line with a gradient of 5, then we know that that must be of the form y equals 5x plus, we'll call it plus p. We don't want to use mx plus c here. We don't want to confuse the c with the c involved in the general equation of a quadratic. So I'm using p here instead of our usual c. So y equals 5x plus p is the equation of our line. What we'll do is we'll substitute that into the parabola in order to try and find p. The key thing here is that we know that this is a tangent. So we do something very similar to the last problem. We're going to rearrange that so that we have x squared, that'll be minus 10x, and plus 10 minus p will be our constant term. We know that this is a tangent, so we know that this quadratic should only have one root, or the b squared minus 4ac should equal 0. So we'll write down our coefficients, a, b, and c. And in this case, that'll be a is 1, b is the coefficient of x, that's minus 10, or sorry, negative 10, and then we've got 10 minus p. We can set up the statement that the discriminant which will be negative 10 squared minus 4 times 1 bracket 10 minus p must equal 0. And this will allow us to work out the value of p. 100, we're going to have minus 40 plus 4p must equal 0. And we'll see that that gives us 4p. 100 minus 40 is 60, but as we've taken 60 away from both sides, that will be negative 60. So p must equal negative 15. So the answer here is that the equation of the tangent must be y equals 5x minus 15. This is our final example in this lesson, and we're going to look at a problem where we have to find the equation of the tangents from the point 0, 3 to the parabola with the equation y equals x squared plus 4. So it's suggesting that there are two tangents here, but we'll proceed very similar to the last example by thinking about what kind of line we must have. If it goes through the point 0, 3, that means we have the y-intercept, so it must be of the form mx plus 3. Again, although we don't know the gradient for this line, we can substitute that line into the parabola, make them equal to each other, as we've done for each problem in this lesson. And we can rearrange that expression so that we have it as a quadratic x squared minus mx, and then we'll be left with plus 1 equals 0. And the key part of this chapter is that because we have a tangent, we know that the discriminant must equal 0. So we're now going to, again, set out our coefficients, a, b, and c. And we're going to set b squared minus 4ac equal to 0. This is a very common technique in these problems in higher maths. And we should certainly get a lot of practice doing this after this lesson. So we're going to have negative m all squared minus 4 times 1 must equal 0, which gives me m squared equals 4, and m must equal plus or minus 2, plus or negative 2. So that actually there are two values of m, and that's why there are two equations for tangents. One of the tangents would be y equals 2x plus 3, and the other one would be for the other value of m, y equals negative 2x plus 3. And these are our two final answers. It's important that you now get some practice with this particular part of the quadratic chapter. If you're studying TJ, you can do that on page 67, exercise H7.5, questions 1e to g I would recommend, and then questions 2 to question 5. Alternatively, if you're studying the Heinemann textbook, and page 161, exercise 8j would be a good exercise to try. Remember, this is just the last lesson in a series of lessons in this chapter that you can access on my channel, and hopefully with practice you'll all be on your way to an A. Thanks for watching, see you next time.